Hello guys, today I have another video of some old footage of the Scania R620. This looks to have been recorded last year around about June, July 2019. So what I'm doing in it basically is wiring in one of the motor driver boards that works with my version 4 vehicle boards. So this is the motor driver board, and what I'm doing here is connecting up the raw power for the board. So that's going to be connected straight to the battery that's kind of built into this model. That's what those first two pins do on the board. And now what I'm doing is positioning the two wires from the main drive motor. So the set of two pins in the middle on that side of the PCB are for motor 1 on the motor driver chip, which is a TB6612FNG. So we have the motor driver connected now for the main drive motor, and now we're just plugging in the control board, the sort of brain of the receiver, to just test out that that part of the wiring is going to work. There's not much point wiring everything if this first stage isn't working. If you look in the top right hand corner of the controller screen, you'll see that the signal bars, we have full signal there. So that means that the controller is receiving feedback from the receiver. It's not really a receiver, it's a transceiver. It sends and receives signals. We're clearly having some trouble here with the main drive motor. It seems to work at low speeds, but as we try to push on, it is starting to fail. So if we look at our signal here, this is our, well, it's supposed to be our 3.3 volt line, but our battery is quite low, and that means that the regulated voltage is below 3.3 volts. It's 3.08 there, and as we try to drive the motor, with each pulse that we send to the motor driver, there's a big current draw, and that is dropping our voltage down to 2.83, and that's around the minimum input voltage for our motor driver chip. So what I suspect is happening is that the voltage is dropping too low, the chip is resetting, and there's probably a safety feature there that won't allow it to just start driving the motor unless it gets the signals from the 0 position. And that seems to be what's happening. If we put the joystick back to the 0 position and then try to accelerate, the motor driver works again. You can see here that I've added a capacitor into the circuit, which is helping at the low speed, but still when we try to accelerate too fast, the current draw is too much. And if we scope this signal, you can see now that our battery is actually discharged more. We're now down to about 2.9 volts, but yet with the capacitor on, the dip in the voltage is not dropping as low as it had been previously. So it's actually working a little bit better with the capacitor. So it might be a case that we just need a larger capacitor, a larger capacity capacitor, to give us a little bit more of a boost. And here we have a larger capacitor. We've probably gone from maybe 10 microfarads or 100 microfarads up to 1000 microfarads. And the reason this works is because the capacitors can deliver current a lot faster than the battery. They can almost deliver the current instantly. The reason we see this issue on this model and maybe not some of the tractors is that the motor in the Scania is actually, it's quite a large motor, so it just takes that little bit more power to get the motor moving. And luckily enough, there's a lot of space in the cab of the Scania, so we've no problem putting a large capacitor in. But I would advise you to use N20 motors for drive motors if you can, because you can get a range of gearboxes, so that you can get very low speed, very high power, or fast speed with less power, but the current draw is always quite low, so it's generally a lot easier to drive the N20 motors than a lot of the larger motors. And here you can see I've just hooked up this little servo motor that does the fifth wheel in this model. This is a awful little servo motor from Hobby King. I think I got like 10 years ago, and it was never really a great servo. It's always kind of noisy, always had this little jitter, and it's probably quite bad here because the battery voltage is so low. We're probably below the minimum of what is advised for the IC in this servo. It's hard to see for the jitter, but it is actually moving back and forward under control, taking the signal from the controller and moving properly. It just happens to be jittering a lot as it does it. In the center of the top of the screen there, you'll see there's another battery, so I've added a second battery. It's probably helped a little, but this servo just is a wee bit jittery. That's just the way it is. I hope you're enjoying the videos. I'm trying to get them up a little bit more regular, well, a lot more regular than I have been for the last year, considering I haven't really uploaded anything. But now that I've a little bit more time at home, I'm trying to make an effort to get the videos up a little bit more regularly. So if you're enjoying them, don't forget to hit the subscribe button and hit the bell on so that you get the notifications. So that was the servo for the steering that we just wired in, and it's a little bit better than the other servo was. It's not as noisy. And here I'd say we're just wiring in some of the LEDs. Yeah, so there's our indicators. That's the way all my models start up. When you're not connected, the hazard lights come on. Of course, you can select your left or right indicator, or you can turn the hazards on using the controller if you wanted to. But they seem to be working as expected, so I guess there's going to be more lights here. No hazards this time, we are already connected. So that's obviously our tail lights coming on when we hit the headlight button on the controller. That seems to be working fine as well. And by process of elimination, I guess this is going to be headlights. Yeah, headlights. So that was the dips and then the full beam. So maybe I'll do it again. So dips, full beam, and that's just a difference in the PWM. So it's probably maybe 60-70% duty cycle for the dips and then 100% for the full beams. And there is our main spotlights. This is probably going to be the lights surrounding the cab. Oh no, it's actually our beacons on the top of the cab. That's also selectable in the code. So this is the flashing sequence that I like, but you can also just get it to alternate left to right, just at a set period if you want it. Or of course you can program it any way you want it if you write your own code. And you seen for a second there we're disconnected, so probably going to turn on the lights here. Yeah, the lights in the grille and the fog lights underneath the headlights and the lights just above the cab. So that was the last few things to be wired there. And this is going to be a signal wire that we can send out to a trailer, so give us control over an accessory. So that would be tipping a trailer or making sure that your LEDs on your trailer are turning on in sequence with the main vehicle. And I'm just kind of squeezing everything back in. There's a good bit of space in the Scania cab, but you'd be surprised how quickly it starts to fill up. So just one screw in now until we test the model, make sure that everything is working. So hazards are on because we're not connected. We select the vehicle and now we have control, so the hazards are off. Steering's working. Main drive working. We seem to have good speed control. There's our headlights with the fogs and those sort of blue LEDs coming on as well. Our main lights are working too, our spotlights. Fifth wheel servo working fine, and our signal to our accessory is working fine. So it doesn't matter what the accessory is, all my boards use the same control signals. So just like you could hook up the baler, you could also hook up the lorry trailer to a tractor and still have the same control. The lights all work the same, no issues with communication between any of the models. Well, I hope you enjoyed that old footage. These kind of problems with the noise and that, they kind of make a build a little bit more interesting, although at the time it can probably seem just irritating more than anything else. But hopefully that gives you some idea how you can get over an issue with that sort of noise. Once you know what the source of the noise is, it's a little bit easier to isolate and to get rid of it. I recorded some footage on the diorama of this model. I'd say I recorded it around about the same time as I done this build. I probably just finished it and then went to test it on the diorama. So I'll put that together in a video which will, I don't know if it'll be next week, but it'll be soon enough. I'm still trying to get through this old videos and make sure that I've got everything uploaded rather than letting stuff go to waste. So that should give you an idea of kind of speed control and just general how accurately the model can be controlled. Maybe I switch some of the lights on and off and things like that just to kind of demonstrate them. But that's for the next video. And this is all I have for this video. So I hope you've enjoyed it. If you did, don't forget to hit the like button, that always helps. And as always, thanks very much for watching.